So today, this is our topic, the future of 3D graphics development. And let's start with the introductions first. My name is Alexey Medvedev. I am working for Meta. I am our tech lead. Meantime, I'm a chair of 3D Formulas working group in Khronos. So if you have questions about glTF, KTX, or what does it mean, you can talk to me afterwards. And I'm passing over introductions to our amazing panelists. Daniel.
Hello, everyone. I'm Daniel. I come from Barcelona. You can notice from my accent. I work for Bentley Systems, the infrastructure software company, not the car company. We always make that bad joke. And I've been all my career working on graphics, digital twins, cloud-based, most of it, and very happy to be here.
Deia.
Hello, my name is Deia. I am an immersive experience designer and creative technologist, previously at Verizon and Disney, and now I own an immersive studio called HYGSF. And I'm going on 5 years as a lens creator in the Snapchat lens network, and I'm super excited to be here. I will be providing a perspective on the design side of glTFs, 3D asset creation, 3D modeling.
Laura.
Hi, I'm Laura Reznikov. I'm an engineering manager at Meta working on avatars. I'm responsible for the performance and visuals team, so performance optimization and general rendering of avatars, making sure they look good across all our surfaces. So I'm mostly bringing perspective on what is our pipeline, how are we handling rendering so many avatars.
Thank you. And Kaiser.
Hi, I'm Kaiser. I lead tech at All3D. We do e-commerce visualization, so creating product photography in computational sets, photo shoots and whatnot, all digitally on your computer. And I come primarily from a background of AI, where we're trying to solve the content creation problem, both in 3D and in 2D.
Thank you very much. And without further ado, let's start. So we have several topics today, and we'll start with the next-gen glTF assets. I will just do a really quick update what's happening in glTF working group, what we're working on. And our vision is we going into the spatial computing. So we picture glTF, the future glTF, as the smart asset will not contain only data itself that describes the geometry or materials, but actually the actual properties of the objects. If you want to place any object in any sort of XR or real environment, you expect a little bit more than just like geometry, right? And our future extensions, they kind of target this direction. We have 4 major directions as for today. It's out of many, but that fits into the spatial direction in general. Interactivity, then complex scenes, physics, and audio. I will cover them. So this is an example of our interactivity graph. So basically, in the future, you can use it as today, but in the future, you can embed descriptive behavior inside the asset. So that means you create the whole program, and you can create the way how you can interact with your object and responses on top of this. So basically what you can see in this video, that's the actual asset. It's only data, everything. There is no code, like additional code, and except the support for the glTF features, such as interactivity. And you can create those rich experiences based on this. Another way to express the animations or kind of complex behavior of the objects is obviously the physics. And we have the incoming extension that allows to create the physical properties of the objects, such as collisions or rigid body shapes. And in this case, that's, again, single asset only that describes the physical properties, and you enable this extension, and you'll see these complex scenes. There is no pre-baked animation. Everything is just physically controlled. Complex scenes is another really important direction for us. glTF itself designed to be the asset, and if you want to compose really rich environment, we want to see the way how we can do this. So that's why we work on the complex scene approach. And by the way, each slide, as you can see, it has QR codes. If you want to follow up on this later, you can just scan it, and you'll see documentation or examples or etc. regarding this feature. And last but not least, the audio. We see the strong demand, again, express the properties of the objects. And audio is a really important part of this as well. We have several extensions incoming, which is supposed to describe the audio spatial emitters or even more complex audio graphs. Here is the example how we can interact between the audio extension, the actual interactivity extension, to create like a whole audio experiences based on the extensions only. Again, zero code from your side except support those extensions. And I have questions to our panelists. So we have a Kaiser here who's really experienced with the e-commerce. And basically we want to see what the e-commerce perspective on this, how important is just like use all the glTF assets characteristics, how important to, instead of hard coding, just using the capability of the assets itself. And what about cross-platform compatibility?
Yeah, so this is pretty critical for us in e-commerce, where our primary customers are the sellers themselves, retailers, people who are going to create a shop on Amazon and Shopify and Etsy, et cetera. We need to have single assets that we can give them as non-technical, non-3D users, where they can distribute that asset to any of the different platforms that they sell on. So having glTF and the open PBR standards where you can create high quality materials and assets that go with them and then just distribute easily is pretty critical.
Thank you. Laura, that's a question to you. What about avatars? How you working, like evolving the capabilities of such complex objects, and what kind of demand we have from this?
Yeah, so for us, we have a bit of a mixed pipeline. So we're starting out with USD for our artists to iterate, work with, collaborate, especially to scale up to all the different permutations we can get with avatars. And from that, we go into kind of a node graph system, a data-driven pipeline that we have in-house to process those. So where glTF then plays in our pipeline is that's actually our transport format for how we get avatars out to every single platform for Meta. So it's all one group working on avatars, working on an avatar SDK, but then we need to deliver those out to stickers. We need to deliver those to your avatar editor. We need to deliver those to Horizon on your MR headsets, on AR headsets, on mobile. So everywhere we have these avatars, we need a format to get them there. So that's what we use glTF for, and it helps us stay consistent and also very dear to my heart, optimized. So no matter people's bandwidth constraints or our memory constraints, like we like to have that nice, neat package at the end after all of our processing to reach all of our customers.
If I can add to that one, yeah. I think from the e-commerce side, two of the ones that we're very excited about are the physics and the interactivity, where when I'm selling a dresser or something that can open, being able to have a 3D asset that actually responds to the user on the website where they want to be able to do that becomes pretty important. And historically, that would be you would need your own engine to make that happen. But with glTF, now we can standardize that and make that usable. And then from the physics side, we have our own internal tool for doing scene creation for our sellers where they want to create the perfect photo shoot scene. And being able to respect physics within that is going to be pretty critical for us. But these being newer features, we're still looking forward to them.
Thank you. And let's move forward for another topic. What about the advanced rendering? So we recognize actually that's one of the important features of the kind of 3D formats in general, just to its ability to scale and basically provide all the functionality to render the content. And it's constantly raised the question, what about the source materials that we are using to create the actual content, and how widely this can be actually distributed, because like the format itself or any sort of 3D formats, they're kind of agnostic to the way how we can render. So we can render on a different kind of devices, starting from the path tracers ended by mobile devices, or like we use photographs as the source. So let's touch this direction. And first question, Kaiser, is for you. What kind of challenges you see when you're trying to approximate the 3D assets from the different diverged sources of the data?
Yeah, this is probably our biggest problem today, is approximating a 3D asset based on some input source material, right? Our sellers coming to us have a wide range of, if we're lucky, it's really high quality CAD files that here's what we sent to manufacturing, and now we just need the 3D asset for taking a nice photograph or whatever. When you're not lucky, it's, I have 3 photographs from the object when it was in the warehouse 2 years ago, and that's all you get. And here's dimension analysis as well, so you know how, the right size. And everywhere in between, you have to come out with something, a 3D asset that's going to be photorealistic and look good in a scene. You can't take any shortcuts. So in the case on the screen here where you have all these different like manufacturing specs and you have to join those into a unified language, there's a whole session on that. I'd point you to the which CAD to commerce video that will be up on YouTube later. But the more exciting one, more exciting to me is, what if you only have a few images and you need to create a 3D asset? And how can you leverage generative AI to create that? And can you put meaning into the 3D space from a purely 2D input? So we spend a lot of time there trying to improve the state of the art on 3D generation.
Yeah, thank you. Deia, same question to you.
On the design side, I focus a lot on the file size. So usually when we're working with glTFs versus FBX versus OBJ, they tend to hold in a lot of different types of information and types of data. So I tend to lean more towards glTF because it's a lighter file size, but it also continues to maintain that like high fidelity that I need. So for instances on like projects in the right video, something that requires like light reflection, metallics, movement, motion, animation that's baked in, I need something that can deliver those things as I create them, and then also when I'm inputting it into the AR experience, it's still a fluid experience for whoever is interacting with my filter. And then again, as Kaiser was saying, talking about 3D AI integration into 3D asset creation, in that left video, Lens Studio 5.0 and above now has this feature where you can do text to 3D asset or image to 3D asset, and it's automatically like a prefab or glTF because it's used for an AR platform. So those types of file types are the best for web AR, social AR experiences, because it holds these heavy amounts of data, but still provides like a smooth performance for any experience that you're creating.
Laura, please tell us about the challenges to produce this large amount, the insane amount of variations for the avatars. You probably really experienced in this challenge.
Yes, painfully. So not only do we have the challenge of, especially with our Style 2 avatars, branching out into parametrics, of users being able to go in and tweak with sliders their avatars to truly generate an avatar that looks and feels like them. So those are a lot of options. And then you start throwing in the different combinations of clothing. And we just opened up clothing to certain creators for them to texture and sell their own clothing. And you can just imagine, ultimately, we want to continue to open that up, and just the number of combinations of when a person loads in as their avatar, what combination of things and parameters could form that avatar, it's huge. Like, representing and delivering that number of combinations is just mind-blowing. It truly is a meta-scale problem. So to kind of handle this right now, we have, again, our USD pipeline, which, thanks to their inheritance and how you can kind of combine different layers, it allows us to very quickly generate all of these different possible assets, and then we have them ingested and processed into our pipeline. So one of the ways that's a bit more advanced on how we're handling all of this in an optimized way is having a data-driven asset pipeline. So this allows us to work on a little bit of a different model. Of a lot of people think of a push model of like, this is my asset, I'm going to push it out to the application. But since we serve so many platforms and use cases, we actually have a pull model. So the application sends a request, and then we say, based on this request, these are the nodes and the processing you need, and these are all the things you don't need. So we're able to go through those configurations to deliver just what we need into the glTF file format. To tie back into your previous question, now that I've had time to think, so one of the things we're using glTF for is our material extensions. So due to the needs of avatars, we're not fully using just the extensions provided by glTF, but it's extensible. So we've added our own extensions to be able to create our own materials and attach those into our glTFs. Also, I know a problem we've had is, hey, emotes are this big popular thing, and with those you want to have animations, you want to have sounds. So with audio, I'm looking forward to bringing back the possible extension of, hey, if we need to deliver emote sounds, well, this sounds like a good way of, you're this fantastical avatar, but this fantastical avatar comes with the specific sound. Well, only that avatar needs it, so let's bundle it just with that avatar.
Thank you. Daniel, question for you. What about large scale for the infrastructure projects, and what kind of challenges you experienced during the development for them?
Yes, our case is quite different. One of the biggest challenges that we have is that when you look at one of those projects, those are not even created from one single project. It's multiple projects into one, so the model is a super model. I remember one of the statistics that we had like 1.5 billion triangles. That's not something you can render with any engine or even in the website. So in our case, we use something called 3D tiles. I don't know how familiar you are, but basically it's a format on top of glTF. So what it does is it takes any kind of project, and then it splits it in different parts, and then for each part you calculate the different levels of detail. So basically, as the camera moves in, you are loading different levels of detail of the project. So it's a little bit like Google Maps with the terrain. As you zoom in, you go streaming data. So I think that that gives us enough flexibility for us to be able to render projects that I remember in 2011, I think, was when I started to work on WebGL. I think WebGL was approved by them. I mean, I could have never dreamed that I would be able to see those kind of projects in the web. Now we can see them, and glTF has something very interesting that I think that we were commenting about the extensions. We are also working now. Paul Connelly, one of our colleagues that is here, and he presented here in AWE. What we are trying to do is add extensions for things like, for example, you can see in the drawing the edges, which is super important for engineers. But not only that, but also line styles, etc. So we are creating and we are proposing extensions to glTF to add that information that we will complement also with more and more things on the GIS space that basically makes glTF like the perfect format to be able to to render those huge projects.
Thank you. And what about the actual possible future rendering features? Like Kaiser, did you explore the Gaussian splats and what you can tell us about that?
Yeah, so Gaussian splats are pretty neat in terms of being able to represent really high fidelity detail in a pretty cheap and fast way. So limited compute and still high fidelity, that's a promising path forward. But going back a few steps, one of the great things that we've recently achieved is finally being somewhat cross-compatible with triangles. We spent 40, 50 years figuring out how do we get a phone and a browser and all the different devices to finally speak the same language of triangles. And so something I'm excited about with Gaussian splats is that they're kind of riding right on the heels, saying, hey, we just figured out this glTF standard where everybody can understand this. Let's bring Gaussian splats into that same level of interoperability where everybody can talk about the same thing and have very large scenes represented with high quality. I'm sure many people have tried out the Snap demo out there, or the Niantic demo out there, where you scan the object and within a few minutes you have something that feels very real, very 3D. But there are inherent limits to that as well. These are effectively fancy point clouds, so they are not very usable in traditional 3D pipelines beyond just kind of looking at them. Although we're doing exciting work on semantic meaning behind the Gaussian splat so that you could actually talk about areas of it and make edits. But yeah, very exciting stuff.
Yeah, thank you. And let's switch gears a little bit. Let's talk about the actual what happens today as emerging applications. Laura, question to you. What are strongest drivers for XR adoption right now? What do you think about?
Well, I think we've seen here a whole lot about e-commerce, but I also want to pull that into social, of like you expand out of an e-commerce, what's available to bigger companies or what even is starting to come to smaller companies. And then I think about the younger generations and the explosion of influencers and how do we make that available so that their content is also the product. So we already see like fully digital influencers and this desire to create 3D content, create interactive content. You have generations that have grown up building on Roblox, building on Horizon now. So I think we're going to see a transition from content creators, influencers going from photo, video to all of a sudden like the next generation of content sharing and influence through 3D graphics.
Amazing. What about the serious business and infrastructural? How you see your XR direction? What kind of challenges you have, or what's different for approach? How you will create for XR? Daniel, that's a question for you. Sorry, I'm looking for you and just forgot to pronounce your name. I'm sorry.
It's okay. It's okay. So one thing that we see is that, for example, we are creating the same content when it comes to CAD data. We create the same content both for the browser and for game engines, because when you stream, you can change the quality of what you have. So and as glTF is getting more and more powerful, you can really get closer to what you will get in game engines. So that is one part, and the other thing that is very important is Gaussian splatting. That is changing a lot because it's simplifying a lot how you can scan the data. That means that we are starting to see different use cases there. But also, before with photogrammetry, we had some limitations. It has some advantages, but some limitations with Gaussian splatting when it comes to, I think that before there was a video about a tower. so you can scan things that before were very difficult, like cables, etc., etc. Now, when you see how you can scan that asset and put it together with CAD data in the same space, that's changing the game, and we are starting to see like different business cases that I think that when we talk about XR, the thing that was missing there was, okay, I can have the CAD data, and we have some challenges there, but when it comes to scanning, things get more complicated. Now with a phone, you can scan it and get something very close to reality. So I think that the Gaussian splatting together with CAD is going to unlock like many use cases that we were like 80% there. I think that we will be able to fill that gap and get the 100% of that business case.
Thank you. Deia, what's your point of view on what's the difference and your experience for creation for XR applications? What about the tools and?
Yeah, so I've experimented with using different types of tools to create 3D assets for my AR experiences. Like I said before, I've done text to 3D modeling, image to 3D modeling, but then also using MCPs to model 3D assets using Blender. That's like my main platform that I tend to create for my experiences. And I think that it helps when you are like in a time crunch, or if you want to expand your skill sets for certain things. So of course I learned the foundation within Blender, but it does take time, it does take a lot of effort, and it's not as cheap. So then I want to, understand like how else I could do this to get the quality I want, get the specific object that I want, if I don't have the necessary resources. So again, using like Lens Studio, because they have this new capability where you can do text to model or image to model, or even MCPs to do Blender, I can use these other outside tools to help fill in the gap for a certain skill set that I do not have just yet, but then also lean on my other colleagues as well when I have questions about how to create these things for these experiences that I'm doing. Quick question though that I had for Daniel, do you think that certain devices matter when it comes to getting these scans and these CAD files for such a large scale of asset that you need for your business, like versus phone or like high-tech cameras? Do you think that plays a part in it? Because I know that sometimes there's like a device limitation when it comes to creating for XR.
Yes, absolutely. I will differentiate two things. One is being to scan. It's different if your device has laser or not, right? That changed the game quite a lot. I'm not an expert in scanning, but even the point clouds has some advantages versus other techniques because Gaussian splatting are great, but they are just on visuals. But with scans, you really have the real information. That's one thing. And so depending on the device, things are very different. The other thing here will be, we are discussing a lot about field applications. I call it a field application when you have the glasses and you want to visualize something here, and you cannot download the whole model. So I think that one thing that we'll have to investigate is loading the content exactly that you need, right? So I'm not talking only about the level of detail, but also what is the content that you really need, right? Because it sounds stupid, but if you have like a huge project and you want to load it in the glasses, that's not going to work, right? So even with animations, streaming just the parts that you want to use. So those are the challenges that I think that we have to think out of the box and not only think about compression, but also about segmentation of parts, level of details, fragments, etc., like materials, and maybe you when you change the materials, just loading that. So I think that those are the things that we have to, on the technical level, we'll have to solve.
Daniel, question for you. We're starting to see a lot of glTF-based assets content almost everywhere, including the actual game products. What kind of difference do you think the people expect from the different variety of the visuals, different platforms? And again, it works like almost everywhere. What kind of expectations for this?
Yes, I think that different use cases will require different formats. And also different quality. So sometimes you will need. Maybe I'm thinking more like my last career, my previous career in games. Sometimes I remember by then we were creating different content for different things. So for example, you could have any. Like a normal asset in a video game, it's different if that asset is going to be part of the main thing. The character is going to take it and throw it away. It's different from the rest of the assets. So we at least we try to get the same content for the different media. But I think that one thing that it's something that I'm talking loud here, which is materiality. How we are going to have maybe different levels of detail with the materials. That's something that, of course, we can do that. But I hope that glTF, as it gets better, or it supports more different materials, I think that's going to be like a game changer, because then we will not only we are talking about simplifying the level of details of the geometries, but also depending on the device and depending on the needs, you are going to load one material or the other. I think that's also tensor rendering, etc. I think that's going to be a game changer.
Thank you. Kaiser, question to you. What about the e-commerce? What kind of value you can get out of 3D assets? What kind of market you see for this?
Yeah, it really bifurcates into the two use cases, right? There's the real-time experience for the customer where they want to do AR, view the asset, spin it around, put it in their room, whatever. And then there's the second side, which is I actually want to spend a decent amount of time making the perfect image of this asset, where it's truly photorealistic and there's no issue with any of the lighting. None of the materials are low res. And one of the promising things about using glTF and PBR is that we actually can scale this thing to say, here's the AR version and here's the render version, the offline render version, and not have to split that as much. Historically, what we've done is we create our glTF and we also create our 3ds Max with V-Ray materials, and managing all that is a true headache.
Yeah, thank you. And I'm just taking out my crystal ball, and I have questions about the future. And we kind of see it's a lot of new use cases, again, interactivity, Gaussian splat, a lot of more advanced features coming in. So how that's a question for all of you, but I will name some of you. How do you think will just all the kind of direction and development will evolve in the future? What kind of, Daniel, question for you, how you see this digital representation, the future of the real objects, real world?
I think one of the questions that some people ask is about CAD data versus Gaussian splatting. I think that those are going to complement each other, and I think that those are going to close the gap I was talking before. One of the problems is that today, if you want to do before we'll talk about the metaverse, right? Let's say that you want to create an application that you are going to sit here and work around and talk to people. The problem is that there are things that you want to take at physical assets that you're going to need CAD data. But the problem is that you need it before a CAD model of the whole building. Normally you don't get it. So those things add a lot of limitations to what you can achieve. But now when you have Gaussian splatting, if we are smart, and now we have the initiatives of having Gaussian splatting with glTF or even Gaussian splatting alone, if you put all together and you select which is the best media, the best format for the assets that you need, basically we can have we can represent the reality, and we can have we can have an avatar there. At the same time, we can scan the room. So the promise of the metaverse, that I know that word, now it's people think like it's an old thing that maybe it's not catching up as 5 years ago, 10 years ago. But it looks like now we can do it, right? And I don't see a lot of people talking about that. We can really do it, and I've seen here Niantic, and also Spixie is, sorry, I don't remember the name of the company, but they are trying to scan the wall with drones, and that's amazing because once you have the wall, I mean, you only have the visuals of the wall, but you want to do things, right? You will want to see cars, you want to see people, you want to interact with things. And I think that now is when XR with Gaussian splatting, also with animations, with CAD data, you can put all together and create it. So I feel, and with avatars too. So I feel that now that we can do it on the technical side, I think that things we will recover that engagement with metaverses or expressions like that.
Thank you. Laura, question to you. What kind of use cases you see that will just rapidly evolve? And what about AI, Gen AI, vibe coding?
Yes. So with Gen AI, I'm also going to expand into neural rendering because I want to touch back to something Kaiser said kind of at the beginning is, okay, file format interrupts. We're talking about Gaussian splatting. Luckily, people are already talking about how to standardize that so we don't get into previous problems where you can't run Gaussian splats everywhere. And then also, it's interesting to have the interop to our formats that our artists are more familiar with, that our hardware is more familiar with, going back to triangles. But I actually want to, in the longer term, challenge that thinking of like, yes, right now, we've all been working with triangles. Our hardware is set up for triangles, but now we're seeing things with neural rendering and inverse rendering of actually understanding 3D and building a new language for 3D, and I almost see it as like the next compression format. So is it just a matter of like thinking about the hardware different, and once we have all this hardware accelerated, will we see a transition? You're seeing neural generation of videos or 3D turntables where it just has an understanding of what the material is, what the lighting is, what it's supposed to look like. And instead of having this thing in a CAD program that you're using your mouse and navigating around in 3D, it just generates what your 2D viewpoint is supposed to look like. It just has an understanding of the 3D. So I'm really thinking in terms of my career and being like, what's next? Being prepared for what's next of the next thing of scene understanding for image generation.
Yeah, amazing. Deia, what do you think about where we are today?
I think that I really feel like, I don't know how people feel about vibe creation, but it's becoming like there's an uptick in that. And I think that is allowing creators, designers to be even more multi-hyphenate. Like I said, I came from a design background, not as technical. I'm a little technical, but when it comes to coding, sculpting, those are skill sets that I'm still trying to improve, but it takes years and years and years. But there are ideas in my head that I want to actualize today, right now. So taking these different individual tools to help me, again, fill in those gaps of skill sets that I just don't have the time to learn all the time, I think there will be, just more of that as we continue to put out more of these programs, specifically AI. So I feel like just more freedom in what you can do with these products, and just being able to put out more of your ideas quicker, individually, because you don't have those skill sets.
Thank you. Kaiser, question to you. What kind of big rocks or kind of barriers remains for us for today to move into this shiny future of perfect 3D, non-distinguishable from real life?
Well, that's an easy one. Let me give you the roadmap. I think it's actually something that, if you think about it 2 years ago, it was kind of a meaningless question because we didn't have the common language to speak. And one of the big barriers that we run into is if you look at the collection of all 3D assets online, all of the ones that have been created, where are they and what formats are they in? The answer is that they're very spread out still, and if you want high quality assets, they're all locked up in the old guard of V-Ray rendering, where you can really eke out the exact material asset that you want. And when we look to the future of vibe creation, as Deia is saying, like if we want to be able to replicate the quality of asset that artists make, you need to be able to represent and understand that asset in the first place. And what glTF has given us is the unified language to understand all of the different assets. But the hard piece now that we have not solved is how do we get everything that's been created into glTF at the same quality level? And then beyond that, how do we train artists to use the new format and say, actually, hey, please create PBR materials that are photorealistic and usable in e-commerce, because it's ready for that in most cases. And once you have that, then the data is there to train on to create the assets. So then we can do vibe creation to scale up to, here's a perfect city of all of the details, photorealistic and everything. The other big one is compute. And as we, push forward into XR worlds of headsets and whatnot, your compute goes down and your quality expectations stay the same, if not get higher, because it's right in front of your eyes. And so you want the 4K at the 1-inch resolution level. And so reaching that's going to be tricky.
And 2 eyes at least 72 frames per second. Yeah.
Better 120, yes. Thank you. So we have, seems like 3 minutes for the questions. And anyone?
Okay. One clarification and then one question. Are Gaussian splats stored in the glTF files now? Is that what y'all are saying, or are they in conjunction with other glTF files?
There's a proposal to add them as part of the glTF file format, right? As an extension.
As today, it's multiple discussions happens. I actually highly recommend. It's a metaversestandardsforum.com. That's a platform when we discuss in different technical issues. Gaussian splat is a really hot topic there. We hosted already 3 town halls when we discussed especially is it too premature to standardize? So that's, we're working on this. But yes, there's an experimental extension that you can use as for today to store this inside the glTF. It not necessarily be true for long term, but yes.
Hi, this is like a user type of question for whether it be e-commerce, avatars, maybe more social material marketing, and then of course the serious like architectural or, high-end enterprise use cases. What is, from each standpoint, the customer, what are they fidgeting around or complaining about or spending the most time in your different areas? What are you seeing the most in like complaints and things like that?
So for us in e-commerce, it pretty much always comes down to the lighting on the material.
Yep.
And so it's actually, the material matters, but the lighting that you put around it tends to matter more. Yeah. So it's like photo op. Yes, yeah, exactly. Doing the photo shoot, making sure it's perfect. Yeah.
Yeah, I'm going to agree with that. Lighting and materials, the consistency across renderers. It's very nice that we do have scalability, and thanks to glTF and some of the standards like OpenPBR or the PBR for glTF, like we have a unified definition of the data of how we want this represented. But then depending on the use cases and how optimized you need to be or how detailed you want to be, there's variations on how those materials, how the shaders are done and how those get rendered out. So consistency across products and platforms when it comes to lighting and shading are still a really hard point. I do recommend there was a peer talk on OpenPBR and different material systems. So that was recorded. So I recommend you check that out too, because it's plaguing us all. It gives us the common data. It gives us the common language. But then the renderers were still like chasing, comparing to a golden render that takes us overnight. But the use cases are different. Like I have to render that avatar, 72 plus frames per second, or crowds of avatars. I can't do a full like path traced PBR.
So on my side, on the design side, so sometimes I will be the customer, like sourcing assets from these different platforms, and the things that I tend to complain about, and like some of my comrades tend to complain about, is how accurate the model is, like when we're sourcing in, when we download it, and then also the size of the file, so triangles matter a lot, but then also how these different programs communicate with one another. If I'm building something in one platform and I move it over and it's gray, it's dull, it's not looking how I want it to look, sometimes it's a user error, but sometimes it's just the way these programs tend to communicate. So those tend to be like the top 3 things that I always hit or just keep in mind when I'm building something out for a client or for like a passion project for myself.
I will try to brief all the different complaints that users can have. So I would say one of the biggest problems that you have, at least in our industry, is the power, how powerful the computer is. Because you think in terms of you're working with the computers, but not all industries, everyone have like huge computers. I mean, maybe some of them may have computers from 10 years ago, or maybe they want to open a model in a very old iPad, and what can you do with a few megabytes of memory and like not non-powerful GPU? It's very complicated, especially with CAD. But it's the same with Gaussian splatting. Another thing which is interesting is that when you're working on architecture or infrastructure, you design the AI model for practical reasons, not for visualization. So it's more about the distances to understand how you're going to build it. So the problem sometimes is that you have a lot of problems with the geometry, like different what's the name of that? Different planes overlapping. So it changes the colors. You see that all the time, and also sometimes you can even have the. You're talking about Z-fighting. Yes, Z-fighting, exactly. Z-fighting of all types, right? Especially imagine like you have like miles and miles of a project, and the user expect like a render, right? It's complicated to do that in real time. And also the other thing is that sometimes they have a model that doesn't have any material, and they expect to see materials. So how do you do it? And we have some research there to automatically with AI finding which material you have using the metadata, which you have a lot of metadata, but sometimes it's more complicated. And finally, that's something that comes even when I was doing video games, is that users sometimes they can take a car that has like gazillions of triangles and just put it there just for fun, and then they duplicate it. And yes, you can. And you can do yes, if you've been in the industry. Yes, I remember like a story when we wanted to publish a game, and we had a deadline, and it was crashing, a level was crashing, and we discovered that's like an artist had modeled a dinosaur of 2 million triangles. The thing, it was like that, and I'm talking about 10 years, 15 years ago, and the worst thing is that it was in a room that you could not get in, so.
I've seen similar of like a little tiny rat that was duplicated and running around everywhere, and it was like something like 30,000 triangles.
Yes, that's, yeah. You cannot control that.
So one of the reasons I think everybody's excited about Gaussian Splat, it's this thing you can just show it examples of what you want, and then you get an asset out. I'm really excited about some of the new like differentiable rendering technology and like differentiable file format stuff. As people who are kind of at the cutting edge of where this is all going, can you talk a little bit about that and like what we might see in that area?
So I think the first thing that I would add, or the thing that I'm most excited about, is that Gaussian splats, as we see them today, are, not to get too technical, they represent an opacity and a color from a viewing angle. And that's a very simplified 3D like what we as humans perceive. There's no reason why you can't change that color function to actually be a 500-dimensional output that has meaning. And it talks about what is the color from, or the color from this angle, but also what's the material from this angle. What's the, what is the object itself doing in this region? And as you have these splats overlap, you can say, okay, that's the fabric right there. And it tells you that based on what it's learned. So I think there's a lot more to be explored in terms of what they actually represent beyond just the image in kind of fun toy image rotation out. Yeah.
Will shamelessly plug into this. Again, this latest town hall we hosted like literally 2 weeks ago. That was the research people who presented exactly the way how they using the trained model to understand what the color means and basically propagate the actual properties for the PBR material as a part of Gaussian splats to be able to represent in any sort of lighting conditions if you want to. So that's a lot of research going in this area as today. And Gaussian splat is only one way to represent the actual radiance fields. It's a lot of research in this area in general. So I think that's sort of the future.
We're also getting a lot of them, which is always a good sign in terms of training new models, where if it's easy to create, then it's going to be easy to train, typically. And so creating 3D assets is hard, training 3D asset generators is hard, creating Gaussian splats is easy. So hopefully we'll be good there.
Just last slide. It's still probably open for a couple of hours. We have a booth. Just please come visit us as Khronos. And thank you.